This is Annalie. When I interviewed Ed Seidel in Edinburgh, one of the stories he told me was about how research in black holes led to the development of web browsers.
Back in the early 1980s and 70s, there was a professor, Larry Smarr, at the University of Illinois, and his PhD thesis was, guess what, colliding black holes.
Yeah.
Okay, so it's a problem people have been working on for a really long time. And Larry was frustrated by the lack of computer power that he had to solve that problem. It's a very hard problem. And so he wound up going to Germany at the Max Planck Institute there, the same institute that where you saw at the Rechenzentrum Garching, the Leibniz Rechenzentrum.
Right.
Larry was going there in the early 80s, and he was using Supercomputers that were in Germany.
Oh, wow.
And he didn't have access to them back in the United States.
Right.
So he came back to the US and he wrote a provocative paper called Supercomputer Famine in America.
Oh.
And so got people's attention that scientists in America didn't have access to the American supercomputers because they weren't provided for them. So that led to the founding of a number of national supercomputing centers in the United States that has been one of the driving forces behind large-scale computing around the world, because the American investments in those facilities have been really very big. Now, that created centers, for example, a place called NCSA at the University of Illinois, where people were working together to solve complex problems like black holes, like fluids in stars, and other things, practical problems like fluid flow in porous media, or diapers, this is, where you have people trying to simulate all kinds of processes like this. And they needed to be able to find visualizations of their data. They would generate very complex data, and they didn't know what it all meant, so they would try to create pictures of it, and that led to a lot of people thinking how you can use pictures to represent scientific data so you can understand it much more easily. That led directly to the development of the web browser. The web browser was the sort of the front end, the visual front end on things like the World Wide Web that came out of particle physics in CERN.
Is that also how the simulations came about, with the visualizations?
Well, the visualizations were there to interpret the simulations. So a simulation is when you take some complex equations that describe some phenomena, like say two black holes colliding, and you solve them. Then you simulate that. You don't actually do the experiment because you don't have black holes in your hands. But you can simulate that on a computer. That generates a lot of data. You have to visualize that. You can make some pretty pictures of it. And then we wanted to be able to share the pictures with each other. So the web browser actually was developed directly in that environment for the scientists to be able to share the data more easily. And then we had very quickly things like Netscape and Internet Explorer based directly on that code that was actually being used early on to share black hole data and particle physics data.
So the web browser that I use on my laptop originated, so to say, with physics?
Yes, absolutely.
Oh, wow.
So you could say that black holes are in some sense responsible for the web browser, or you could say that Albert Einstein is responsible for the web browser if you trace back the needs of the scientists.
So what do you tell a computer? How does it then simulate the collision, so to say? What do you tell the computer to do?
Well, there are some equations that you use in order to, that Einstein gave us a century ago. And for the last century, we've just been trying to figure out how to solve those equations. And so the equations say, effectively, you have to multiply, add, you have to subtract. They tell you that those equations describe those kinds of operations, and there are lots and lots of them. There's so many of them that you have to do literally many billions of calculations in order to simulate something like two black holes colliding.
All right. But do you need a special program? I'm guessing you do, but a special program on the computer.
You need special programs. You can't just buy a black hole program at Walmart or something like that. You have to write it yourself, okay? And so you have to have enough computer skills in order to be able to take a blank sheet of paper or a blank screen and then start writing a code, a computer program. So maybe if you're doing programming as you're in school or something like that, you might know C or Java or some language. So we use those exact same languages to describe the problems of black holes.
But you've come up with a program yourself then? Then it's not something that was existing before?
Sure.
it's developed as technology.
We write our own codes, and we
Okay.
had to do it in a collaborative way. So people in my group developed a thing called Cactus, the Cactus
Okay.
framework for computing, for high-performance computing. And it's a kind of a collaborative tool. And basically it just says, if you write some kind of a routine and I write some kind of a routine according to some rules, then they'll work together. So maybe you're an expert in, say, the gravity part of a problem, and I'm an expert in maybe the fluids, how do they move according to the gravity. So you'd write a piece, I'd write a piece, and we
We'd
put
work
them
it together.
together,
Okay.
and then we could solve a problem of fluids near a black hole, or of gas falling into a black hole.